Good morning, good afternoon, good evening. Thanks for joining us here. We're coming to you from the beautiful city of Eindhoven in the Netherlands. My name is Nazanin Shafiee, and I'm the Business Development Manager at SmartPhotonics. As you can tell from the title of my talk, today we'll talk about the importance of coherent sources and the requirement of low-power chips for the massive interconnect bandwidth. Today, I'd like to tell you about SmartPhotonics. We'll have a look at the trends that we see in data center interconnects. We'll talk about the challenges that are often raised by the industry and how photonic integration offers a very elegant solution for all of these demands and challenges. And lastly, we'll go over your product development needs and how you can take advantage of our Foundry platform and services. I imagine most of you know SmartPhotonics, but for those of you who don't, here we go. We are an independent pure-play foundry for indium phosphide-based photonic components and photonic integrated circuits, PICs. As a pure-play and as an indium phosphide foundry, we're unique in the industry in being 100% focused on developing and manufacturing for our customers, rather than producing our own components on the side. So in essence, we don't compete with our customers because there is no conflict of interest. And our customers don't have to worry about their IP and can count on our expertise to help them develop a product from proof of concept and prototyping all the way to volume manufacturing. Now, SmartPhotonics has a long history in photonics, coming from Philips and Technical University of Eindhoven. We've got a strong foundation on two main pillars, being research and manufacturing. From 2012, we started growing as a separate entity, where we started production, expanded our tool base, grew our team, expanded our manufacturing facility. We have a very diverse team, and as of now, we have 19 nationalities from around the world, and over 750 years of combined photonics and semiconductor processing experience. And for those of you following the news, earlier this year, we secured a 35 million euro investment, and we're recognized as Europe's leading independent foundry for integrated photonics. Our plan is to increase our capacity by tenfolds. Let's now change gears and talk about data center trends. I expect that this isn't going to come as a surprise to anyone, that we're seeing a data explosion, leading to record high shipments of transceivers. Demand for all products, ranging from 100G to 400G. This has been obviously driven by the 5G mobile managing bandwidth requirements. But this demand is changing. Legacy products are going through a gradual decline while 400G products are continuing to grow. We are seeing a transition from QSFP28 CSFP transceiver modules to higher density QSFP-DD OFSP modules. We're seeing PAM4 coherent DWDM signaling as predominant architecture for intra-DC, metro, and long haul. COVID-19 has affected the telecommunication globally. It's negatively impacted the sales of the optical transceiver modules in 2020. That said, the optical transceiver market will more than double by 2025. So you can say the market is on track to set a new annual record in the coming years. What's driving this data explosion? The growth in social networks, digital entertainment, cloud computing, Internet of Things. These are all radically driving the growth of data centers. And what's becoming more evident is the need for high bandwidth, low latency, low power consumption fiber-based communications. IEEE, after completing the 400G spec, began working on developing an Ethernet bandwidth assessment. to see what was happening in terms of bandwidth trends. What you see here is an excerpt from the report which was recently done, and it shows the data demand in terms of networking traffic. The traffic is now normalized back to 2017. So what you see here is a growth anywhere from 2.3 to 55.7 times the traffic of 2017. It's just an absolute incredible number. And the fact is that the bandwidth demand is outpacing the ability of the industry to respond. Around 2015, we saw the 10G DWDM modules with tunable lasers being deployed. And then we saw the slight transition to 100G, 200G coherent sources in 2017. And another transition in mid-2018 to 400G coherent sources. And we also expect the 800G and beyond to be in the not-so-distant future. And what do we need to align to this ecosystem that is changing so rapidly? Pluggable optics. By not changing the operating model that much, other than moving the optics inside and potentially offering power savings. As we said, to accommodate the strong growth in data traffic, the fiber optic infrastructure that allows data to be communicated between network nodes and within data centers has to be upgraded. The fiber optic networks are a combination of long, medium, and short optical interconnects, and they range anywhere from approximately 3 meters to over 1,000 kilometers. As I'm sure you know, there are various form factors and standards for these optical transceivers, and they're often identified by the packaging and the optics. The first set of characters identifying the packaging type, and the second set identifying the data rate. Now, the packaging is important to determine what devices, for instance, switches, routers, network interface cards, can support the transceiver. And the optic indicates the data rate, or the reach that it can achieve. There are a lot of inputs and constraints, and as the system vendors move into higher and higher speeds, they are trying to get the technology into smaller and smaller form factors. The graph you see here shows the direction the industry is moving towards to meet the higher bandwidth density. The blue circles on the top right, they're representing the 400G solutions, with the OSFPs and the QSFP-DD modules being on the frontiers. Let's now talk about the challenges that the datacom industry is facing. Before we go over these challenges, let's keep in mind that right now, the bandwidth demand is outpacing the ability of the industry to respond. So it's absolutely critical that we help address these challenges. Briefly, these challenges are being able to produce cost-effective modules, being able to meet the required high performance, being able to reduce power consumption while meeting the optical module performance, and of course, reliability and easy system diagnosis. It's obviously not enough to have a solution. What's going to need to happen is not going to be just about getting to a solution with 400G modules or beyond. It's not. It's going to be about a cost-effective solution. A cost-effective system favors simplicity, and a fully integrated system on a chip can offer that simplicity and cost saving, because it can have a significant impact on reducing the most cost-bearing aspects of module manufacturing, being assembly, packaging, and testing. The second generation QSFP-DD modules for 400G, with its increased bandwidth density, will still need to meet the small footprints dictated by the requirements, because it needs to be backward compatible with its predecessors. One of the challenges that's being voiced by the industry is the power demand of the modules. When looking to design the next generation data centers for 400G and beyond, what you hear from companies like Microsoft is that the power they're starting to demand from these components is actually preventing them from growing data centers to the scale they would like to. It's forcing them to build more data centers, which they prefer not to. Building new data centers is actually quite expensive. So you can imagine how badly these industries would like to be able to use their existing data centers and grow within it. Another thing to mention is that the higher power consuming modules have a higher upkeep cost. There is a cost to power, and it's not a one-time upfront cost. This is an ongoing cost. So lower power consuming modules are not just desirable, they are a key consideration. The next challenge is reliability. Robust and well-integrated systems are needed to reduce the chances of equipment failure. Keep in mind, coupling optics is a potential source of failure, which can be removed by having a system on a chip. And the last point, no matter how reliable the modules may be, it's still extremely important to be able to do easy and rapid diagnosis of modules, components, and subcomponents. Again, system and component diagnosis favors simplicity. With a reduction of the number of components in a module, we can make that possible. So having talked about the industry challenges, let's now talk about the photonic integration and how it can offer a solution to the challenges we talked about. Monolithic photonic integration offers an elegant solution to the challenges we talked about. And indium phosphide is the only platform that can offer photonic integration monolithically. And because of it, it can offer smaller footprint, higher performance, reduced power consumption. It eliminates the need for coupling optics. And the chips are highly reliable and robust. All of this, plus the added benefit of reduced cost. Something worth highlighting on the performance side is that indium phosphide is the only platform to provide an option for ultra-high baud rate modulators. That's 90 plus gigabaud. And indium phosphide also provides better modulator performance for high baud rate applications. So what's needed is a coherent transceiver. And a coherent transceiver is a complex circuit with a lot of different active and passive components, all of which you can put on one indium phosphide chip. This is critical, of course, for the form factor that's needed for the QSFP-DD modules. I'd like to show you some of the must-haves for this integration for coherent transceivers. There are not a lot of examples that I'm allowed to share, but I do have a few key ones which I'm sure you'll appreciate. On this slide, I've got an example of a PIC. This chip is a nice example of our platform capability with simple building blocks from our PDK, with which you can make very dense integration. Here you see 6 Mach-Zehnder modulators and 6 over 22 nanometer tunable lasers, all combined in one channel to get a 100 gigabit per second transmitter on a single chip. You've got a continuous sweep tunable laser without any power change at large bandwidths. This laser can be tuned at continuous range by just turning a dial. In this example, this chip can go up to 25 gigabaud. We show a very reasonable bandwidth already with this circuit as is. And the components I mentioned are the most important building blocks for the 400G base ZR. So not only can you see a PIC being demonstrated here, in my next slide, you'll see this done for one of our customers, showing the high quality and reproducibility of this complex PIC. As you see, we have a great control over the integrated components we manufacture. This here is a commercially available product with nice reproducible data. Looking at the timing jitter, eye opening, you see we have a very large margin, so you have lots of room to play with when going to higher bandwidths. This is a great example. Actually, no, this is more than a great example. This is the ideal source for a coherent transceiver. This is a tunable laser which is needed for a coherent transceiver. It's low line width and full band tunable. This chip is done in C-band, but just as easily transferable to O-band as well. It's got complex string laser with multiple tuning sections. The dimensions of the waveguides are very well controlled on our process, and similarly, we've got great control over our phase shifters. You can make very affordable, high-quality laser by just using our PDKN platform. So far, you've seen how badly coherent sources are needed. We've seen how integration is critical for coherent sources. I showed you our high-quality reproducible modulators. I showed you our low line width full band tunable lasers. And these, as I said earlier, are the most important building blocks that you'll need for a coherent source. We have a fancy scanner litho tool, which we really like. And here's why. By using our scanner, you can reduce your losses by more than a factor of 5 times in an AWG. Now, you don't need an arrayed waveguide grating for a coherent source, but the fact is that aside from our platform capability, we have fantastic process capability. We have a scanner with a very high resolution and throughput, with which you can get high resolution components and rapidly. The big advantage here, going from 300 nanometer to 100 nanometer, is that you're reducing your losses, as I said, by more than a factor of 5 times. And this is what's also applicable to the Mach-Zehnder modulators, which are important for coherent sources. So we know what it takes to make coherent transceivers. Remember the power issues we talked about earlier? Here, you're looking at a single channel laser operating at 45 degrees Celsius, where it's most efficient. The whole module operates over the full operation range of -40 to 85 degrees Celsius, and below the operation power requirements for the threshold of this module. We understand the applications. We have in-gas-based devices commercially available. And for coherent sources, you need in-L gas chips to allow them to operate at higher temperatures. So it results to lower power consumption. The full monolithic integration of all components on indium phosphide eliminates coupling losses between several components and also further reduces the power consumption. What's more is that there is no question on chip reliability. Lumentum, an indium phosphide chip manufacturer, ships transceivers at 1 million parts per year level with 20 to 30-year lifetime specs. Infinera has WDM technology shipping into 20 to 30-year lifetime undersea networks. 100 million hours of operation in live networks worldwide without any peak failures. That's evidence of high reliability. Here I'd like to show you the cost breakdown of a DWDM 10G SFP Plus and a high-end coherent transceiver. On the y-axis, we have the currency normalized with respect to de facto industry standards, which is being compared to silicon photonics and indium phosphide platform. Here we can address the simplicity we talked about earlier. The simplicity that monolithic integration of indium phosphide platform offers leads to cost saving. on optical components, assembly, and packaging. The de facto industry standard uses gold box. Using silicon platform, you can reduce the optical component cost because you can put them on one die. But you will still need the silicon chip and a number of indium phosphide chips that you need to place together, which, as you see, adds quite significantly to the cost. There's a significant cost in optical assembly, additional optical components, and of course, you need to package the whole thing. And as you see, the cost on an indium phosphide platform drops drastically. The costs for indium phosphide and silicon chips are not that different. But for indium phosphide, you can have it all monolithically in one chip. Optical assembly is much easier because you need only a couple of fibers. You don't need much auxiliary optics. You only need an isolator, and that's it. And the packaging cost is all the same. And the more active components you need to integrate, the more it makes sense to do it monolithically on indium phosphide. On the bottom right image, on this high-end coherent transceiver, do you see that with the indium phosphide, you have about a quarter of the cost, a factor of 4 times cost saving because you can do full integration. Now, let's talk about your product development needs and how we at SmartPhotonics can play an integral role. By working with us, you can take advantage of our PDK, our tested building blocks, and of course, the controlled processes. We have our PDK available in multiple software packages for simulation, design, and layout. Obviously, having these building blocks makes the design faster and more accurate, but also your development costs will be less. SmartPhotonics offered the world's first commercial MPW run on indium phosphide in 2013. At that time, MPW runs started every quarter, but now we've increased the frequency to 6 times per year due to demand. It's a fantastic platform because it offers low threshold access to the new technology. But we also offer dedicated wafer manufacturing. And with these, customers can go from proof of concept to prototyping and pilot. And for all of our customers, we take them all the way to full production and commercialization. We'd love to meet you and answer any questions you may have. Please send us an email, give us a call, let us know about your development needs, because we're ready to hear it. Just to wrap up, SmartPhotonics is a proud member of EPIC and a foundry partner of the JEPEX pilot line. If you have a design or prototype you're working on, please talk to us. But also check out the JEPEX pilot line project and see if you're eligible to take advantage of the great incentives they're offering. With that, I'd like to thank you for lending me your ear and open the floor for any questions you may have.